Well, hello, old friend. I've been waiting a very long time for this day. This is an IBM 5160, also known as the XT, despite the missing hard drive. And this machine is particularly special to me because this is one of the quintessential systems from my childhood. My household first acquired one when I was about 6 years old. We actually had a couple of them, including one with the elusive EGA monitor, the 5154. In fact, the XT might have been the single greatest influence on my interest in tech. I probably wouldn't be in such an advanced role career-wise without it, and it's for that reason I view these machines with such reverence. Sure, we had Apple IIs at school, but I only had IBM systems at home, and the XT was my homie. And I've been looking for one of these things for years, but I just couldn't stomach the prices people asked for them. So what better way to acquire one than spending thousands of dollars on an e-waste haul? That's right, I picked up another one. And there's a lot of gems in this one, including a Mac clone made by Motorola, and a Tandy 2500 that's sorely in need of some love. There's more details in a video covering that haul on my Patreon page. Well, I really can't wait any longer. Let's get into this XT. And it is almost surreal to have an XT on my bench, finally. It's almost ineffable how happy this makes me. And we have two full-height 5¼ disk drives, both IBM original, although the XT is supposed to have a hard drive here. It's kind of an interesting choice that somebody opted to swap that out. Unless there was some spec of the XT that didn't have a hard drive that I don't know about. This double disk drive setup is more similar to an IBM 5150. I don't know, maybe they were using this machine to copy disks or something. So we will need to get a hard drive in there. And of course I have one. This is a 10 megabyte Seagate ST412, and that's one of the models of hard drives this machine would have originally been spec'd with. I picked this up at VCF West last year for just such an occasion. See, it's not hoarding. It's preparedness. It even has the appropriate IBM branding up there. I don't know if it works, so we'll find that out. But if it doesn't, I have a couple other period correct options. And it's so funny to compare these monsters to modern hard drives that we're all familiar with today. All that space gets you a whole 10 megabytes, which should be enough for anyone, right? And that IBM badge is fortunately almost perfect, no damage whatsoever, and seeing it again sure triggers some core memories. And these disk drive latches function perfectly. They're not broken, which is common on this style of drive. I'm not sure if IBM drives ever had that problem, and I'm pretty sure these are made by Tandon, and these drives are also branded IBM. And here's a view of the side of the machine. And of course, being an XT, it has the crazy satisfying power toggle switch. Yeah, talk about feeling like you're starting up a spaceship. And here's the back of the machine. You see the power supply takes about half of the width of this thing. And this is the power port for the monitor. That allowed you to turn on both the computer and the monitor with just the switch. In fact, most IBM monitors from this era can only accept power through this connector, unless you just plug a regular IEC cord into it. And here's the keyboard port. This of course takes an AT keyboard, and this is also one of the ways you can tell an XT from an original IBM PC, aka 5150. The 5150 would have a cassette port here, right next to the keyboard port, so there'd be two DIN connectors side by side. And we have a connector for an external floppy drive. Got our parallel port here, our 25-pin serial port, and this is the graphics card. I'm not yet sure if it's monochrome CGA or EGA, but this was long before the VGA era. That's why it uses a DB9 connector. We also have composite video output, and we might have to use that, because I actually don't have a CGA monitor. I do have a monochrome monitor, but it's currently untested. And that would be this amber phosphor leading edge monitor, which is monochrome of course. This monitor was also a VCF foundling, specifically VCF Southeast. However, if this system has either CGA or EGA graphics, I won't be able to use this monitor. Monochrome or MDA is not compatible. And this monitor does have some sketchiness on the data and power cables, but that's honestly the least of my concerns. That's easy enough to fix. And hey, it's got the IEC connector for plugging into that power supply. Although I'm probably changing out this cord anyway, just because of that damage. And now, for the first time in more than 25 years probably, Mike's going to open up an XT. And of course, this being a machine deserving of respect, we're going to use a 1/4" socket instead of a flathead screwdriver. And once that's done, this cover just slides off, and I mean all the way off. You gotta take it all the way to the front of the machine. And this one's hanging up. There we go. Wow, everything about this system triggers me. Even seeing the empty outer shell. And there it is, in all of its XT glory. And that's an interesting way to leave the terminating resistor on the disk drive. They just lifted the whole half of the chip and left it in there. We also have several pins lifted on the jumper block here on this disk drive. I'm going to have to get the manual and see what that means. We also have a resistor bodged across these two connectors here. That certainly doesn't look factory. There's quite a bit of globulation going on those solder joints. I wonder what they were trying to accomplish there. And this machine uses an AMD 8088 CPU, as opposed to one made by Intel. And some XTs did come with AMD CPUs, so that could be original. And we are missing the math coprocessor, which would go in the slot above it. And I see we are missing an MFM controller. That's kind of no surprise because this doesn't have a hard drive. But it may just dash my hopes of getting that hard drive working, because I don't think I have an 8-bit MFM controller. I'm going to have to dig real deep. But let's see what we do have. Starting with the floppy controller. And we have an NEC branded chip there, D765AC. And all through-hole components. Gotta love the 80s. And this card is interesting. It provides our serial and parallel ports. Looks like it's also a RAM expansion board. Does this machine have 640K? We'll have to see. It looks like it also has an RTC on it. Let's get that cable off. Yeah, that's a battery. So that's gotta have an RTC. In this time period, that was not something that came standard on the motherboard. You had to manually set the date and time every time the machine boots. Let's just get this parallel breakout shield out of the way. And let's pull that card. Oh, that's a 6-pack plus with fully populated RAM. Well, as far as RAM expansion cards go, this is one of the nicer ones to have. It's made by AST. Fun fact, AST started out by manufacturing add-ons like this for the IBM PC, before joining the Clone Wars and manufacturing whole systems themselves. And we got a little burn spot over there. Where did that come from? There's nothing burned on this card. Oh, I see it. There's a failed tantalum on the graphics card. IBM systems of this vintage are notorious for that, and we may have a few blow up on the motherboard when you try to power it on. It shouldn't hurt anything. Hopefully I'll be able to identify the bad ones before they do blow up. And that looks every bit like an original IBM card, if the failed tantalum didn't give it away. So let's pull it out. Oh, that screw is already loose. And we're marked color graphics, which means CGA. It also means we can't use that monochrome leading edge monitor. Composite it is, I guess. We've got some numbers back here too. I just love these massive full-length cards. Okay, let's go ahead and get these disk drives out of here. You know, this was a lot easier when I had child-sized fingers. Didn't realize how difficult these Molex connectors were to reach. There we go. And somebody already removed the bottom screws that secure the other side of the drive, so we just got to remove these. There we go. And let's pull that cable out of there. And there's that motherboard. I don't see any blown up tantalums yet. And since that one on the CGA card was blown up, somebody must have tried to power this thing on semi recently. And the fact that I don't see any blown up on the motherboard probably indicates they're all in okay health, or at least at the health level it's not in imminent danger of exploding. And this is funny. No copying permitted. Yeah, that'll stop the clones. For sure. Okay, let's go ahead and pull this motherboard. That speaker disconnected. And the power supply. There we go. And hey, we got a little tag on that speaker. So a date of May 1985. I'm not quite sure what the rest of those codes mean, but it's cool that this is still in there. Let's see, there's nothing on the back. Yeah. Well, that's neat. And yeah, we have no exploded tantalums. At least not yet. And I'm pleased to see we're fully populated with RAM. That's what these chips are, over here. Let's get this board dedusted. There, that's better. Now let's do a quick check for shorted tantalums. Now this is not a perfect test because these may not have gone short yet. Sometimes that only happens when power is applied, but let's just see. Okay, that's no trouble. That just means they're charging. Good there. And these two are ground, so we're going to get shorts, obviously. These next two pins are also ground. We got something shorted on the number 4 pin on the P9 connector, and that is on the 5-volt rail, so something may be short indeed. Let's just check the rest of them. Okay, yeah, we got a short on 5-volt rail, so we're gonna have to find that. But you know, on second thought, that may not be a short. That may just be below the resistance threshold that this meter considers a short, but we should probably check anyway. And one way to check for shorts is with a bench power supply. Just set it to a really low voltage and a reasonably high current. In this case, 1 volt and half an amp. Just connect that on the points of the board that you suspect to be shorted. And let's turn it on and see what we get. Okay, the fact that we're only drawing 0.16 amps tells me it's probably not shorted. Or at least not shorted yet. Let's just go ahead and scan the board for hot spots using a thermal camera. This was given to me by a dear patron of mine. It's actually a phone. It has all kinds of nifty tools built in. Let's see, what is that? Is that a cap? Maybe. Doesn't actually feel hot. Here's a problem with infrared cameras. Sometimes reflective surfaces can look like heat signatures. So we'll come back to that. Let's come over here. And what is that? Okay, that is definitely a reflective surface. Yeah, that's that shiny part. Yeah, I'm not seeing anything else. I just have some false positives, which are just shiny parts, like the empty math coprocessor socket up there. That is definitely not hot, but it is shiny. Now, coming back to this supposed hotspot, it actually looks like it's that chip, and it's not hot, but it does have a little shiny spot on it. I'd say we're good, at least for now. But if one of these tantalums blows up, it's not the end of the world. They typically don't damage anything, and sometimes you can just snip them off and they'll be fine. So we'll just have to wait and see. Okay, let's move on to these disk drives. Gonna have to get this logic board off. Man, this whole system is really dusty. It must have quite a few hours on it. Let's get this thing cleaned out. Now let's just carefully clean those heads. Not bad. Now I don't think those rails need grease. Let's see if that head's stuck at all. Nope. Moves perfectly freely. Just got the jitteriness of the stepper motor. That's totally normal. That could be all this drive needs. Hopefully the heads are still in alignment. And it is a Tandem TM102A, manufactured December 2nd, 1986. Let's check out that spindle. Moves freely. Seems like that belt has plenty of traction, and it does. We should be good, but let's see how easily it rotates with a disc in there. Yep, perfectly fine. This drive might be good, assuming it doesn't need any adjustments. That's what this tachometer pattern is here for. That's a strobe wheel that tells you the RPM of the spindle, which is of course adjustable. Okay, let's do the same thing for the other drive. And that's about the same level of dust, so these drives must have been twinsies for quite a while. And that is the same model drive, though more than a year older. Let's see how that spindle feels. Feels great. Belt has plenty of life. Head moves freely. Assuming everything's in spec, we should be good. Now let's check out that power supply. We've got a date code there, which I take to mean the 47th week of 1985. Possibly. Now we're going to go ahead and ignore all of these warnings and take this thing apart. But just because I do doesn't mean you should, unless you're already familiar with the risks associated with working on power supplies, of which there are many. And to further drive that point home, IBM has this thing buttoned up with some T10 security Torx screws. That's not going to keep me out though. And that sure looks like a blown fuse to me. Let's check it. Yep, it's blown. Let's see if we can find out why. Okay, after going way too deep into this thing, there isn't any visual indicators of issues, but this Schottky diode right here is short. But you know, there really isn't anything special about this power supply, apart from its case form factor. A standard AT power supply will work just fine to power this system. So I think what I'll do is just replace this thing's guts with modern power supply components. But you know, that's a better idea anyway. Well, if I'm gonna do it, I might as well get it done. Let's go ahead and gut this thing. It's very important that I preserve this switch here. No classic IBM would be complete without one. And I realized a little too late that those ground pins were not part of the board. It's actually this separate bracket. I could have just left that soldered on. Oh well, let that be a warning in case you're trying something similar at home. Well, that escalated quickly. So what unholy abomination am I concocting? Well, I decided to just gut a regular high-quality AT power supply, and I'm just going to shoehorn it into the XT's power supply case, which is totally not going to involve copious amounts of hot glue. Okay, yeah, it is. This is probably going to be temporary-ish. I'll probably dive back into this eventually because the cables on the AT power supply are crazy long. Obviously, this is intended to be in a tower. That's going to make my XT kind of cluttered. But I still prefer this over trusting that very old power supply. And don't worry, I promise I know what I'm doing. And that being said, don't try this at home, especially this. But there's no way I'm going to let my first XT experience in nearly 30 years be without this giant toggle switch. That is 90% of the reason I'm doing all this. The things I do for nostalgia. And you know, this is not even the hackiest thing I've ever done. Not even close. So I've got 4 plastic standoffs, one on each corner of the board. That helps raise it up off the metal. I've also got the insulating plastic under there, just in case. And everything's held together securely with that fine substance, hot glue. And for the input voltage selector switch, I'm probably just going to insulate it and stick it to the side somewhere. This is all temporary, you know? I even harvested the fan connector for fully cromulent fan connectivity. And now that I got this thing in there, I better make sure that fan actually fits. Oh ho ho, just barely. That heatsink comes close, but it does not hit. So we are good. It's too bad I couldn't center it up better, so that both heatsinks are under the fan. Those metal tabs down there kind of made that impossible. But I think it'll get more than enough airflow. Speaking of that fan, let's see how that thing's living. This fan is very important to the XT machine sound scheme, so we have to make sure it is right. I don't know if it's coming through the microphone, but it's very windy outside. Hopefully that doesn't interfere. Well, let's see. Oh yeah, I definitely remember that sound. I'm gonna put the microphone up close for those who know what I mean. All it's missing is the hard drive sounds. And as a side note, that fan bearing sounds perfect, so all we have to do is clean this thing up and get it back together. Okay, now, time to answer the question that everyone's probably wondering at this point. Is this thing gonna kill us all? Let's find out. Nope, works just fine. And I already knew that power supply was good, so no need for an extended test. And to whom it may concern, this retrofit, if you want to call it that, is completely reversible. The only real permanent change I made was removing the fan connector from that board, which is no problem to reinstall. Just in case I decide I want to make this thing original, If I decide I really want a numbers matching XT, I'll go ahead and rebuild this power supply. But as of right now, the power supply I swapped in is superior in just about every way, including available current on the 5-volt rail. These old systems are more heavily reliant on the 5-volt rail than the 12-volt rail, so that's a consideration you have to take if you're trying to retrofit these power supplies. And I did notice that pin 2 is missing on the P8 connector of the original power supply. Don't know why, I'm not sure if it matters, but I went ahead and popped it out of the replacement power supply just in case. You never know, and it's better to be safe. But all the voltages check out, and they all match what's on the label of the power supply, so we are good to move on. It's time to figure out what I'm doing about this hard drive. This is the oldest MFM controller that I have in my possession, at least as far as I know. And as you can see, it is 16-bit. So this is intended for an AT class machine. Now it is possible that it might work in an 8-bit slot, but there's no guarantees at all, and it would at best be partially working. Okay, scratch that idea. Through the magic of the video getting delayed, a couple of the MFM cards that I ordered from eBay came in. We've got a Western Digital card up there, and an original IBM Zebek card. I think that's how you pronounce that. Zebek? I'm not sure I've ever had to pronounce it before. But this is one of the original cards that would have came with the machine, so it is currently our best bet, and it has the added bonus of being one of the configurable cards. It has a switch block here. One thing that's slightly concerning is that BIOS ROM is exposed. These have little glass windows on top that's used for erasing them. It's probably fine. It normally takes pretty powerful light to erase them, but let me go ahead and get some tape on that just in case. Keep your memory. Hopefully it still has it, because I don't think I have any compatible ROM chips. And of course, being from eBay, these are both completely untested, but I think we'll start with the Zebek card first, being original and all. But before we get into that, let's go ahead and address this blown capacitor on the CGA card. According to the internet, a very helpful website called -0degrees.net, that's a 10 microfarad 16-volt capacitor, and supposedly we don't even need it, because its only purpose in life is to filter the 12-volt supply from this connector here, which we aren't using, so we could just snip this off and be fine, but let's just give it a chance. I do like to fix things properly once in a while. And since you're more than likely replacing these with 2-legged capacitors, there's no need to worry about leaving the other hole open. You just have to bend the legs of the capacitor such that it'll fit there. And there we go. Now let's just solder that down. Let's flux it up. And that cap's a bit long-legged. Let's trim those. Now let's clean it up. Done and done. Okay, now let's try to do something about this crack in the drive faceplate. It's cracked in the most important part, the IBM logo. I should be able to just glue it. I've already got it unscrewed, so let's just flip it around. Since it's not structural, this gel-type superglue should be fine. Just need to do my best to keep it from oozing out of the front side. And sorry for how horribly out of frame this is. I just realized that. I really need to get an overhead camera mount. Okay, I've given that more than enough time to dry. I put some painter's tape on there as a finger substitute, so I didn't have to hold it for 12 hours. Let's see what we got. Well, it held together. Good enough. At least it's not about to break off anymore. Okay, this case needs some serious dedustification. Can't believe that little power supply fan drew this much dust in. And this case is in great shape. It even has all of its original cork feet, and no nasty corrosion anywhere. Okay, now, let's do a little pre-test. I'm going to go ahead and power on just the motherboard, because I want to see if any tantalums explode. So let's find out. Oh, that is a great sign. No explosions, and we get beep codes. Alright, that motherboard's healthy. Let's go ahead and get everything back in there. And since I'm putting a hard drive in here, I'm going to go down a single floppy disk configuration, which means I need to chromulate that terminating resistor. So let's get it out and back in proper. Ew, those are some bent pins. Let me fix that. There we go. And by the way, if you're in a pickle, you can just use 8 150 ohm resistors across these pins. And that's all this thing does. And not that it really matters on an XT, but let's check or replace that RTC battery. And yep, it's definitely dead. But there's one small problem with that. The battery on the card is a BR2325, and the closest thing I have on hand to replace that is a CR2025. That should be close enough in thickness, but I think it's going to be smaller in diameter. And it looks like it's yeah, a little smaller. And I can probably just jank it in there temporarily. They're both 3 volts and obviously not rechargeable. Yeah, I guess I'll just do that. It'll do for now. Okay, we have one small problem. With the addition of the hard drive controller, I now have 3 full-length cards. The problem is I only have 2 of those plastic card supports. So let me see if I can find at least one more. And the Horde provides. Well, let's see if those little plastic pegs line up in there. And they do. It's a little bit loose, but the card will hold it in. On second thought, I better give that 6-pack plus card one more space. That thing holds in there better than I thought. Alright, that worked out. Now let's get some drives in here. And there is another small problem. The longest MFM data cable I have can't reach the drive. Now I could put the hard drive in this bay, but that's just wrong. I want to preserve that original XT look, so I'm going to have to elongate that cable. I figure I'll just sacrifice one of my crazy long floppy cables. The ends of these cables are actually just crimped on. However, I don't have the correct crimping tool for that, so I'm going to have to crimp those by hand. We'll see how well that goes. Okay, I got all those connectors stripped off, and this cable's pretty gross, so let's clean it up. Now it's time to get the connectors off the data cable. And I'm going to have to be super ginger careful with these, because I'd really prefer them not to break. And I only have 2 of these cables, so I only get 2 tries at this. Okay, that went well. Alright, no breakage at all. These old cables are constructed a lot better than the floppy cable, but that is just half the battle though. I do have the other end. Alright, that went well too. Now let's exfiltrate that cable without damaging those pins. There we go. That went very well. Now let's get the other end off. Oh no, those are pulling out of there. I have to be a little more careful with this. Well, I guess they're going to come out. That's okay. I'll get them back in there. They should be fine. Okay, now let's peel off 20 pins worth of cable. I'm going for maximum length, so I'm leaving all these twisty parts on there. I'm just not going to twist them when they're terminated. Done. Now it's time to attempt termination. I'm going to try to get this on camera as best I can, but I got to get real up close and personal with this. Let's see if I can reuse the pre-existing termination holes. Okay, to my eyes, it looks like each conductor is terminated. Let's check. Alright, we're off to a good start. Let's go to the next one. Hey, I think we're in good shape. Maybe I didn't need that special tool after all. I think this is starting to turn into the primitive technology tech channel, and perhaps it'll in some way come in handy during the apocalypse. Oh, by the way, here's a faster way to check these. Just swipe across the top of the ribbon cable here until you hear a beep. And that one's good. That is making this go a lot faster. And that's the last one. This side is good. Okay, let's reassemble then. Let's see if I can get that rollover to be as pretty as the factory. Yeah, not too bad. Alright, let's do the other end. Now, I'm not sure if this side is going to be easier because the pins are more spaced apart, or harder because the cable is split in 3 pieces. Well, let's find out. Oh yeah, that's a lot easier. You just push it in until you start getting stabbed. And that should be enough to hold it in place while I press down with the chip lifter. You know, I find these tools are far more useful beyond their main job of lifting ICs. Okay, those are all seated. And now for the real continuity test. Hey, we've got our first success. Let's see, are we gonna win? Maybe. Maybe. I'm also checking adjacent pins for shorts because some of those little knife pins are kind of close to each other. And that's the last pin with no shorts. I think this cable might work. Let's go ahead and close it up. Now let's tape over these battle wounds. This is by no means a permanent thing. This is just a get the system working type hack job deal. And I'd say that cable's not going to have any trouble reaching the drive at all. And for the control cable, I'm just going to use a regular floppy cable. That should work just fine as long as I connect the drive before the twist. That's also going to require the drive to have a terminating resistor, which this drive does. So we should be all good. So let's get this thing in there. And you know, I didn't realize how much latent childish excitement this would evoke. I sure hope this drive works. It's pretty corroded, so there's a chance that it doesn't. I'm gonna have to flip that cable. That barely fits. And if it doesn't completely work, hopefully it just barely works. I at least want to hear those sounds. Here, I better tidy up that control cable. There we go. Let's screw that down. Alright, got that floppy drive back in. We are just about ready to test. There is perhaps one last hurdle though. Since it's been nearly 3 decades since I've worked on or even touched an XT, I just barely remembered that I'm not going to be able to use an AT keyboard with this machine. XT class systems don't understand AT scan codes, even though they use the same connector, and I don't have a Model F or anything, so I dug up 3 potential possibilities. I basically just pulled out all the keyboards with a DIN connector that lack a Windows key. I'm fairly certain these are all AT keyboards, and none of them have any switches for selecting XT or AT class. But you know what? I'm holding out hope. I'm going to start with this MMG keyboard because it sounds kind of cool. And I am taking capture from the composite output, so hopefully that works. Well kids, it's the real moment of truth. It's time to see if we get a smoke show. There's still a pretty good chance some tantalums will explode on that CGA card, and possibly on that hard drive controller, but it's time to finally see, does the XT live? Oh, it is posting! Look at that! That thing works! And no smoke yet! I say yet. Could still happen. And we got a keyboard error, so I guess it doesn't like this MMG keyboard. But yeah, slowly counting RAM. Though, it didn't count up that 6-pack plus card. Thought that was supposed to take it up to 640K. Yeah, we got errors, and no way to get past them either, because I bet it doesn't understand its F1 key. Let's see. Nope. Well, I might need to get me an XT to AT adapter, which means this video is going to get delayed yet again, because you need an actual active converter for that. You can't just use one of these adapters. We need active logic to convert the scan codes. Well, just to see, let's try those other keyboards. And one other thing, it doesn't sound or feel like that hard drive is spinning. I know it does at least spin up. I tested that after VCF, so maybe it's not happy with the controller or one of the cables. Okay, let's try this filthy yellow abomination. I also disconnected both the data and control cables from that hard drive, and I still don't hear it spinning. And we still have a 301 error, so that is also an AT keyboard. So that's no good. And this Epson keyboard connector is kind of wacky. It's very oddly shaped and doesn't fit in there at all. Doesn't even begin to reach. This keyboard probably came from a word processor or something, but at least they give you this handy little tab to pull it out with. But it doesn't do me any good, so I guess I'm ordering that adapter. Let's hope they ship fast. Well, in the meantime, let's see if we can help this ailing hard drive. And I noticed that superglue already gave up. Why is superglue so useless? I swear, it's not good for anything. Really, the only thing I've ever successfully used it for is temporarily holding it in place while a better adhesive takes hold. Anyway, superglue ran over. I've got a power supply connected to this thing, so let's see. Okay, I heard a click, so maybe the spindle motor just can't get going. I wonder what are the chances if I just like shake it, if it'll... Nope. And that logic board's getting kind of warm. Particularly this giant resistor here. Actually, all of these giant resistors are getting about the same temperature, but that could be normal, seeing as they're so big and raised up off the PCB. Well, let's take a look at the other side of the PCB, why not? Oh, well, think I found the problem. This power connector is disconnected. I don't know how on earth that happened. I don't remember disconnecting it. And it doesn't seem very easy to come disconnected. That's got to be power for the spindle motor. Well, let's try again. No, that didn't do it. Unless that connector is oxidized. Okay, continuing investigation. Okay, the PCB is off, and here's the spindle motor. Let's see if I can turn it. And don't worry, the head is parked. And it's kind of sticky. Kind of really sticky. But it does turn. Yeah, we definitely have some perished oil or grease in that bearing. Gotta see if it's possible for me to rectify that. Okay, I decided to go a bit mad scientist on this. I discovered that the motor control board actually operates completely independently from the main logic board. So I got it connected to a bench power supply. So I think if I harass the motor a little bit while applying power, maybe it'll catch. I've actually been working it quite a bit and it's a lot more loose now. So let's see if we have any luck. Oh, that's doing a lot more than it was. And the current dropped off, so that means it gave up. Let me just power cycle it again. Okay, yeah, I guess that's a sticky part now. Let's see. Do you just need some help? Oh, got some current spikes. Oh. There it goes. The bearing sounds terrible, but it's running. Look at that. That thing's going. No way. I can't believe that's what it took. Well, the bearing's starting to sound a little better. Well, maybe not. Oh, goodness. That sounds dreadful. The head is definitely still parked, so I don't think it's a head crash. Could be, though. I really don't know the condition of this drive. I honestly must be misremembering when I said it spun up before. That bearing just sounds so ill. I'm hoping that maybe the internal grease will like distribute or something. Okay, I've had this thing running for a while now. Just hoping that bearing would straighten itself out. And it's a lot quieter than it was. And the current draw is a lot lower too, so I guess that means less rolling resistance on the bearing. Time heals all wounds, I guess. Maybe this drive will make a recovery. And hey, my keyboard adapter came in. I got this from techselect.com. No affiliation. Paid my own money for it. No idea if it'll work, but supposedly it uses the same circuitry that the keyboards with the AT XT switch use. So hopefully this is the last piece of the XT puzzle. Maybe I can finally test this thing properly. Let's see. And since that adapter has a PS2 port, I'm guessing we can use a PS2 keyboard. And what better choice than the Model M? It's not exactly a Model F, but at least we get that delicious buckling spring sound. Lovely. Let's fire this thing up. Okay, we have no post. What is going on? Okay, well, I did forget to reconnect the control cable for the hard drive, but that shouldn't stop it from posting. Oh, no, there it goes. That was odd delay. That could be capture device shenanigans too. Okay, so we got error 1701 and error 601. I'm sure at least one of those is due to the hard disk controller, so let's just get that fixed up. Alright, once again. Okay, we got video a lot faster that time. And we still got an error 601, and I'm pretty sure that's a floppy controller error. Maybe we just have some dirty edge connectors somewhere. Well, nevertheless, let's see if we can continue, since we don't have any keyboard errors anymore. Aha, we sure can. Although obviously we're not getting anywhere. Parity check 2, what's going on? Something made a groaning sound. I'm not sure what that was. The hard drive stepper motor hasn't moved, at least I didn't see it move. Let me try power cycling it and pay attention this time. Oh, it is the hard drive head moving. Okay, well that explains its confusion. Obviously we haven't low-level formatted this hard drive yet. Let's see if we can figure out what's wrong with that disk drive. Oh, well, you know what? It'd probably help if I set the cable correctly. I've got the non-twisted end connected, which is in the middle of the cable. And we need the twisty end. See how the conductors in the middle of the cable here are twisted? That's what tells the system that this is A drive. So let's just swap that out. I forgot what an exercise in cable management XTs were. Yeah, it doesn't help that we have all these extra power cables. This thing has more Molex connectors than an XT will ever need. Okay, let's try again. And because I'm feeling optimistic, let's get a DOS boot disk in there. Once again. That little hard drive bearing sounding better and better. I think this exercise is doing it some good. Ooh, heard the drive. We're doing something. And we are booting. Let's just skip date and time for now. There it is. The XT is alive. Oh man, you don't know how happy that makes me. I can't even find the words. Alright, well this is a pretty blank disk. This is just a IBM DOS boot disk courtesy of our PS1. So I don't think we have anything beyond system files on here. Yep, command.com only. Okay, next order of business. We've got to low-level format that hard drive. Now I could use the DOS debug command for that, but I would much rather use IBM's advanced diagnostics disk. And I've got that on disk 2, also courtesy of the PS1. So let's get that in there. Let's give it a hard reboot. Alright, there we are. Now it has been a lot of years since I've done this, so bear with me. I think it's system checkout. Let's try that. Ooh, that looked a little funny. I think my capture device is really having a hard time with this. My input is also severely delayed. But we did detect a fixed disk drive and adapter. I'm going to say this list is correct. I like that psychedelic initialization thing. I gotta get a real monitor on this thing. Okay, now I think we hit 0 again for run tests one time. And then we select the fixed disk adapter, 17. And as tempted as I am to run those tests, let's just jump straight to the format for now. So we'll select 2. And that is going to be C drive. Big scary warning. Yes, we definitely want to continue. Alright, it's performing. And yes, we got drive activity light, and the head is moving. I think we're doing it. Yep, that stepper motor is just ever so slightly advancing. We should be getting towards the end of the head travel soon. Yep, just returned back to 0. Now it's doing a jittery thing. It looks a little funny. I don't know if that's a good sign or not. I can't imagine that drive is super healthy after its recent health scare. I can't exactly remember how long this is supposed to take, but it's been doing this funny little pattern here for about 5 minutes now. But it is advancing though, so maybe that means it's doing what it's supposed to do. I'm just going to go ahead and hold out hope. Okay, I let this thing run for about 40 minutes maybe, not exactly sure, but it did stop, and it stopped right in the middle of the disk. And I also lost video output, so I think something went wrong. Looking back on the video capture, I didn't get any errors or indication of failure. It just went straight to no video signal. So I guess I'll try to reboot this thing, and then run the hard drive tests. And since the head is in the middle of the disk, I'm going to try to make this quick, so that it doesn't completely spin down. Okay, the hard drive head just parked itself, but I still have no video signal. Yeah, I think something went wrong. Let me just give it a full power down. Give the capacitors time to drain. Alright, let's see if that's long enough. Okay, yeah, I got nothing. It's time to start diagnostics. Okay, I pulled all the peripheral cards. Let's see if we at least get beep complaints. And we do not. Something is horribly wrong. Okay, I did a quick test of all the motherboard's power supply pins again, and they're all good. So let's just do a quick minimum systems diagnostic test. That basically just means nothing else connected to the motherboard except for a speaker and a power supply, and also nothing else connected to the power supply, including the drives. And this test also requires that number 5 or 6 on that switch block needs to be set to off. In this case, switch 5 is already set to off, so we're good. So let's see if we get beeps. Yeah, still no beeps. Gotta go deeper. Aha! Do you see what I see? I see capacitor C56 exploded. That wasn't like that when I did my initial inspection, so that must have happened during the low-level format. But you know, usually these things fail pretty spectacularly, so I don't see how I didn't notice it. It must have happened when I walked away from the system. I did go to the other side of the garage briefly, so it must have happened then. Well, let's go ahead and get it replaced. Okay, out you go again. Okay, let's see if that was enough. It was not. Okay, now I want to try deoxing and reseating all the chips. Okay, let's see if that changed anything. And yes, it did! We are back to complaining. That's far better than being dead. Okay, let's put the graphics card back in there because I'm curious about that RAM count. 320K seems suspiciously low, especially with that AST 6-pack Plus in there. So let's see what it's reporting now. Okay, CGA card is in. Let's see. Okay, now we're back to doing nothing. What is the deal? Well, maybe the CGA card is going bad. Let's see if we still at least get complaints. Turn that off. Get that out of there. Come on, beep codes. Okay, now that is weird. It was just working, and so I put that card in there. And now we're back to being completely dead. Well, I guess this is going to take some more advanced diagnostics. Okay, I got the post analyzer card in there. Now the post code is going to be useless because XTs don't really have that. That really wasn't a thing until the AT standard. But at least this will tell us voltages, whether it's stuck in reset and got a good clock signal, stuff like that. So let's see. Man, we got a bunch of random post codes. That almost looks like it's writing garbage to the bus. And I see we don't have minus 12 volts, but honestly, we don't need it. That's not required for the system to run, but it is suspicious. But the CPU did come out of reset. We do have a clock signal. It's almost making me think there's a faulty ROM chip or something. But let's trace down that negative 12 volt rail. Let's start with the simplest thing first. Let's give that power connector a wiggle. Ah, that LED's starting to light up when I twist this connector. And the post codes are changing. Or, they're not actually post codes, they're just random garbage. Yeah, there it is. Minus 12 volt LED is lit up now. Is this really just a faulty power connector? Could I possibly get that lucky? I'm sure if that voltage rail is screwy, then the rest of them are. Actually, before we do that, let's just try another power supply. You can power these with a modern ATX power supply through an adapter. You just don't get the minus 5 volt rail, but we really don't need it. At least not for this test. The minus 5 volt rail is just for the peripheral cards. So let's see what happens. And it looks like very much the same thing. No beep codes. Yeah, I think this thing has some kind of logic problem. Okay, so we're going to go slightly more advanced. Well, I haven't used the oscilloscope in a while. Let's go ahead and probulate that CPU. I've got the pinout for the 8088 on the screen there. Hopefully it's visible enough. So let's turn this motherboard back on. Oh, and now it wants to live. What is going on with this thing? Literally all I did was move it. Okay, well, while it seemingly wants to work, let's go ahead and get some baseline readings, I guess. Let's just have a look at the clock. Obviously it's good because it sounds like it's working. And yep, good clock, 4.77 megahertz. Now let's just hit these address/data lines. See what we got for activity. Looking good there. Okay there. You know, that leading pulse looks a little low, but that could be still within TTL range. Let's continue. And that one looks even lower. See how the two shorter pulses are lower voltage than that long pulse. Seems a little suspicious. Moving on. And that one looks more normal. That one looks fine. And that one looks a little funny too. Let me try to zoom in a little bit. Okay, that's too zoomed. Let's go to 5 volt divisions. Well, I guess it looks okay. That little tail pulse has to be below TTL range, or the range of ambiguity. Okay, now let's probulate the RAM, just to see if everything or anything is in order. Starting with the parity bits. This is the data in pin. That looks good. Move on to bank 1. Looking good. Bank 2. Same. And bank 3. All good. Now let's make sure the data out pins look decent. And that should be this pin up here. No data out, but that could be because they're not selected. Yeah, I don't think parity is active because right now it's just erroring out. Okay, moving on to the actual RAM. Bit 0. Okay, we got data going in there, but that looks a little funny. We're 4 volts peak to peak, but one of those peaks is half. Okay, let's move on. And bank 1 looks the same, as does bank 2. And bank 3. Looks a little troublesome. Let's see if we're at least getting data out on these. And we are. Okay, so maybe at least the RAM chips are working. Anyway, let's move on to bit 1. Same as bit 0. Same, same, and same. Let's check data out on these. Alright, all the same stuff going on in bit 1. Let's go to bit 2. Looking weird. Same, same, and same. And bit 3. Okay, that's definitely not right. It's being held high with a little dip right in the middle there. Let's see if they're all like that. And they are. Wonder if we have column address strobe problems. Let's check data out. And we got the same stuff going on there. Okay, so bit 3 is sus. Well, let's go to bit 4. And it's got that same weird activity, but at least it's better than what's going on in bit 3. All looking very samey. Okay, bit 5. Okay, bit 5 is doing that same thing too, being held high and dipping low. Same thing across all banks. Okay, so bit 5 is also suspicious. How about 6? 6 is okay, I guess. And bit 7. Bit 7 is doing that thing also. So what do bits 3, 5, and 7 have in common? Okay, I just got the machine back in its failed state, and now I only have activity on the parity bit. See, nice square wave there, but on every other, we've got that weird false signal, and some of these bits are being held high. We don't even have that little dip. So I'm just going to go up the bank here. That one's held high. That one's got the weird dip. Weird dip. Same, same, and same. Oh, nope, that's being held high with some very brief dips. And now it seems that all of the chips are doing that, except for the chips on the parity bit. Okay, so I think that definitely confirms there's a problem with the logic that's driving the RAM. So let's dive into that. The intermittent nature of this problem makes me think this must be due to some failing TTL chip somewhere. And according to the technical reference guide, the RAM is buffered by this 74LS245N chip here, or U9, and that connects to the CPU through another 74LS245N. But for right now, let's go ahead and probe this chip, see if anything looks funny about it. And the machine is in the failed state right now. So let's just look at the side of the chip that's coming from the other bus transceiver that connects to the CPU. And that's going to be pins 2 through 9. Let's give them a probe. Okay, no activity on 1. Let's just go down the line. 2 looks normal. And 3 looks normal. That's address line 3, not pin 3. 4 is good. As is 5. And 6. 7 has nothing. Maybe it's not supposed to, I don't know. And 8 is doing weird things. Okay, so now let's look at the other side of the chip that actually connects to the RAM banks. And that's going to be pins 11 through 18. So I'll just start at 18, why not? Let's just B1. And it's being held high. Oh, no, maybe not. Let me get a better connection on there. Okay, yeah, that's being held high. Go to pin 2, or B2. And there's that weird dippy signal again. Let's just continue down the line. Got weird dippiness on B3. Also B4. And B5. B6 is held high. Also B7. And B8 is weird and dippy. Okay, now there should be nothing else between this side of the chip and the RAM banks, if I'm reading the block diagram correctly. So next step is just pull all the RAM chips, see if anything looks different on that bus transceiver. Okay, all the RAM's removed, and I'm doing that to rule out the possibility of a bad RAM chip messing with the bus. So let's just probulate again, starting on B1. And that's still being held high. B2 hasn't changed, neither has B3, nor B4. B5 is also unchanged. B6 held high. Pretty sure that was the way it was before. 7, same. And B8, no change. Let's just make sure we have activity on the enable pin. And we do. So at least that logic is working. How about the direction pin? Yep, lots of activity there. Let me actually get my second meter probe and see if the direction pulse is lining up with signals on B2 or B3. Whichever one actually had signals. Okay, I got my second oscilloscope probe down there. That's the blue line. Now let's try to trigger off the enable pin and see if any of those weird pulses follow. I think this pin, yep, and they sure do. Okay, so maybe that is somewhat normal, but that still doesn't explain why some of these are being held high, like this pin here. So it might just still be a hunch, but let's just go ahead and replace that chip. And here's our target, in case I forget. Stranger things have happened. flux that up. Now let's see if the desoldering alloy is any match for these notoriously heat-soaky IBM boards. It did fine on the capacitors, but ICs are quite a different ball game. It also doesn't help that these pins are bent. Okay, I am having to apply just the gentlest amount of prying under the chip. Not even barely finger weight. Now at this point I should be able to just lift it off topside. There we go. Now let's get all this cleaned up. Now I would be remiss if I didn't socket this chip. The problem is, I don't have any DIP 20 sockets on hand. So does that mean I'm going to use a 14 and a 6? Absolutely. Like a glove. Okay, I better resolder that cap that I harassed in the process. Clean up, clean up. There we go. Okay, the replacement bus transceiver is in. Got all the RAM back in. What do we get? Alright, we got the initial beep codes, but crucially, does it do it again after a power cycle? That seems to be the most reliable way to trigger the fault. Let's see. Ooh, I've never been so happy to hear error codes. I wonder if that was it. Let's get a video card back in here. And we have a memory count. Made it to 256. That seems perfectly cromulent. Okay, 301 and 601 are normal. I don't have a keyboard or disk controller connected, but I think we're finally good to proceed. Okay, now, with all that out of the way, let's try that low-level format again. And I left the 6-pack plus card out this time, just to reduce the potential number of things going wrong. Alright, let's go. Okay, we got RAM count. C8000 ROM. I think that might have to do with the hard drive controller. Maybe I just don't have a good connection. Let me try reseating that. Okay, that connector is cleaned and deoxed. So once again, still have issues. Well, the phenomenon known as bit rot is not uncommon on these old ROMs. Let's just see if I can get past it. I doubt it. Okay, this thing still has more issues. Okay, I got the board back on the tribulation station. I rechecked all the signals on the RAM, and everything does look good. And this time I remembered to check the RAM refresh signal, and it's fine. So I wonder if we maybe have a bad RAM chip, or several. So what I'm going to do is I'm going to drop down to just one bank of memory. That should give us 64K, and I just have to make the relevant change on the switch block. You're setting switches 3 and 4 to on. Now let's see if we get any stability out of this thing. Okay, let's try this again for, what, the 50th time now? Okay, counted up 64K RAM, and no complaints yet. Okay, finally, sounds like some good things are happening. Okay, we're back in the diagnostics program. Well, let's just try that low-level format again. Okay, well, it crashed. It just rebooted itself and came up with this parity check 1 error. So at this point I think it's unlikely that the RAM chips are the problem. I'm honestly leaning more towards the BIOS ROMs now. Yeah, might as well just get right to it. I've got the latest revision burned onto some EEPROMs here. We'll give that a try. If that doesn't work, I'll try a diagnostic ROM. Yeah, with as old as these ROMs are, it's not surprising for them to experience something called bit rot, which is exactly what it sounds like. They just slowly lose their memory over time. Well, let's see if that helps. Okay, we still have errors. It's entirely possible the BIOS on that hard drive controller is also corrupt. But we also have a 601 error, which is the floppy drive. I'm not completely sure why. I thought I fixed that. Let's just see if we can continue. The drive's working, and it booted. Okay, so that's even weirder. No, I didn't bump the switch block. Either way, let's see how far we can get with system checkout now. Okay, yeah, it thinks it has 2 disk drives. I must have hit that switch block somehow. So let me shut down and double check that. Okay, yeah, my number 7 switch was off somehow. No idea how that happened. Let's try again. Well, that takes care of the disk drive error, and now the hard drive controller is having trouble. Maybe that was just the end of the line for the BIOS on that board. Okay, never mind. For some reason, moving the data cable from J2 to J3 did the trick. And we booted with no errors, and we got a fixed disk again. So I guess let's try low-level formatting again. Yes, that's correct. Let's go through this again. 17. Format fixed disk. Drive C. Yes, I'm sure. Alright, we've got some head stepper motor action. See if we get better results this time. Okay, now we're on to that head workout routine. I still don't know if that's normal. I don't remember that being a thing. Okay, well, that looks like that was successful. It did take 3 hours, though, so that is definitely not right. But the important thing is the system remains stable, which is a vast improvement over the way it was. Okay, well, let's get into DOS and see if we can lay a file system on this thing. Before I do that, though, let's just give it its XT countenance back. That'll be better for airflow anyway. These old systems get pretty warm. And let's get our DOS boot disk in there. Let's go. Alright, good RAM count. Happy sounds. And I think we're stuck. It's possible that this version of IBM DOS needs more RAM. I still only have 64K in there. Well, let's get the RAM back in. Okay, I got all 256K back in there. Switch block set accordingly. Let's see if we're any better. Okay, once more. Alright, it's looking good. And there we are. Let me make sure I even have F-disk on here. Apparently not. Stand by. The trusty PS1 saves the day again. Oh, that's not good. But I wonder if it's the controller or the hard drive itself. Let's boot back up to diagnostics and run some tests. Control-Alt-Delete. Alright, system checkout. Well, this is correct. Run test one time. On the fixed disk adapter. And I guess 0. C drive. Sure, why not? Okay, well, I'm guessing that means bad things. It didn't complain specifically. Okay, well, how about measurements test? Okay, the hard drive's doing stuff. Keep going. Keep going. No indication of success or failure. We run 0 again. Okay, same thing. Be nice to know if that worked or not. Okay, well, there's a reason I bought 2 hard drive controllers, so it's time to engage Plan B. Let's try the Western Digital card. Though my general feeling is the hard drive probably is the issue. But since we can, let's go ahead and rule out the controller. Let's see. And with this controller, you get into the format utility using the debug command. I think that's G equals C800:5. Let's see. Aha, there it is. Alright, select drive C. Default interleave is fine, I guess. We are not dynamically configuring this drive. Jumper settings on that card should be fine for an ST412. Alright, we are ready to begin. Alright, looks like it's doing it. I see the head advancing. And it looks like it's making a second pass. Do you want to format bad tracks? I don't have the defect list for this, so let's just say no here. Alright, we're ready to reboot. Let's go. Alright, let's see what we got. Same error. Well, the first time I was on MS-DOS, I guess as a last-ditch effort, I'll try MS-DOS again. Right now, it's not looking good for that hard drive. Okay, here we are on MS-DOS. So we get anything different? Nope. That hard drive might be hosed. Well, let's see if we can even read the boot sector off this drive. We can do that with the debug command. Ew, I don't have the debug command on here. Oops. Okay, guess we're booting back to IBM DOS. There we go, back in IBM DOS. And I got a little program here to read the MBR off the disk, hopefully. It's actually assembly language. Okay, let's go ahead and run that. And I should have read the MBR into RAM if it read it at all. Wasn't even paying attention to the hard drive indicator. So let's display that. Okay, well that's data. It's garbage data, but it's kind of what you expect with being unformatted. I could actually try zeroing out the boot sector. Yeah, let's do that and see if we get any different data. I'm actually going to reboot so I get a perfectly clean environment. Okay, let's enter that program. Uh-oh, what did I do? Oh, I typed a 1 instead of an L. Okay, let's run that. Alright, got some CPU registers and flags. Now, let's rerun that first program. Okay, now. Okay, that is similar but slightly different garbage. So I wonder if that's just reading whatever's in RAM. But I did notice hard drive activity when I did that. So maybe not all hope is lost for the ST412. Okay, well, we're getting no love from the ST412, but what kind of hoarder would I be if I didn't have a backup plan? This is that NOS Seagate ST225 that I picked up at VCF Southeast last year. Still in its original plastic, although it was taken out. It definitely looks brand new, or at least never used. We also have some documentation with it. Got the factory test output. Doesn't seem to have any surface defects, and also comes with its installation handbook. So if this drive doesn't work, I'll be surprised. So out with the old. And in with the slightly less old. And that of course means we're going to have to reconfigure the hard drive controller. That should only involve populating 4 jumpers on this header here, the lower parts. So let's do that. Alright, let's get it back in there. Alright, do we get spin up? Sounds like it. Yeah, it sounds happy as can be. No complaints from the system. Now let's low-level format that. Yeah, ready. Alright, that drive is doing stuff. And no defects on this drive that we know of, so no to that. And let's reboot. Alright, F-disk. Are you happy now? Ooh, it got some garbage on the screen, but it did detect the hard drive. Let's see if we can partition it. Yes, we want to use all that space. All 20 megabytes. Alright, let's reboot and try to format it. Oh, looks like it wants to. And it's formatting. And it correctly detected the capacity. And it's just a clicking away. Alright, just finished. Let's give it a label. Alright, no apparent badness. Let's try to copy some stuff onto it. And it is copying. Alright, that is a healthy drive. Let's boot up to DOS 622 and run ScanDisk on it. Aha! We don't have enough memory for ScanDisk. I forgot about that little quirk. Well, anyway, while we're here, let's go ahead and make C drive bootable. But first, let's delete all that IBM DOS stuff I put on there. There we go. Oh, I don't have the sys command on here. Oops. One moment. That little PS1 is earning its keep today. Alright, let's go ahead and copy ScanDisk over to the hard drive. And now that I'm reasonably confident in the health of this machine, let's go ahead and reinstall this 6-pack Plus card, see if that gives us enough RAM for ScanDisk. That is one spin down sound. Yeah, I'm not going to worry about the parallel port breakout shield just yet. And also, let's try to boot from the hard drive. Alright. You know, that seems like an awfully low RAM count for all the chips that are on that card. I need to look at that. And the hard drive is booting. Let's see if that's enough memory for ScanDisk. Oh, that's a different error. Interesting. You know, I'm fairly confident that 6-pack Plus should be getting us to 640K. It's time to take a closer look at that thing. Okay, these switch block settings should be correct. I didn't change them. And I believe there's 384K on this card. At least these switch block settings are correct for 384K. For the third board revision, that is. I'm not completely sure which revision this board is, because it's not marked. But it's possible one or more of these chips are bad. I believe a bad chip will stop the RAM count, And I don't have a chip tester, so I might need to try the brute force method for finding the bad chip. That involves going down to one bank and then just switching the chips out until you find the bad one. That sounds just tedious enough to work. So we'll set the switch block to 64K. Now I have to figure out which bank is bank 0. Okay, this manual is weird. It only shows 3 memory banks, but I'm gonna guess that the rightmost bank is gonna be bank 0 on our card. Okay, we're down to what I think is bank 0 only. This is really just a cromulence check to make sure we're still counting up to 320K. And we are, so that confirms that. Now let's populate the second bank. And just to mix it up, I'm using the chips that were in banks 5 and 6. Got the switch block set. Let's see what this does. Aha! We're over 320. We are definitely on to something. Okay, I'm just going to continue on like that until I find a bad one. Okay, I'm on the 6th bank, and we're at 640. Okay, well, I'm not complaining, but I'm wondering what was wrong. Maybe they just needed to be reseeded. Well, hey, I'll take it. Let's see if ScanDisk runs now. Ah, yes it does. In a very weird mode. I thought I'd get some color. And we got some snow. Alright, let's do the surface scan. Yeah, that sporadic interference pattern is called snow. I forget how to get rid of that, but I remember there being a command or something called no snow. Fairly sure I used that only on my 5150. I don't remember it being a problem on the 5160. Then again, I never used the composite port for video. And what do you know? This drive actually is defect-free. Yes, indeed. Well, that's awesome. So at this point, we do actually have a fully functioning XT now. And this could actually be the most satisfied with a system resurrection that I've been to date. Let's just shut it down for now, and observe that marvelous spin-down sound. Beautiful. Well, let's go ahead and test that other floppy drive. I just have to move the terminating resistor over from the other one. And I've replicated that bridge here, because I guess that's important. And I just took that old shunt block out since it was pretty messed up anyway. Let's get this in there. And let's get old T-Res in there. And of course a boot disk. Alright, let's go. Oh! Something just smoked on there as soon as it went to seek. What was that? Sure that didn't damage anything. It's almost impossible to see, but there's a teeny tiny hole in this inductor here. So I guess that's what let the smoke out. Okay, well, I'll have to find a replacement for that. But for right now, at least I have a working drive, so I'm happy. But I wonder if it has anything to do with this bodge here, because that's not on the other drive. I didn't even think to remove that. No idea what it even does. Okay, well, I guess I'm putting the other drive back in here. Okay, I can't give up on the ST412 that easily. Let's get in the speed store and run some tests on it. Okay, it sees the drive. Let's do manual setup. And let's set the type because that's clearly wrong. For drive 1. And there it is. Error, seek operation failed. Okay, we already got errors. Well, let's go to diagnostics and see how bad it is. Let's do a seek test. Extremes to middle. And it's doing it. And that bearing's starting to make nasty sounds again. Okay, well that's extreme to middle, alright. Now it's doing random. Okay, well all of those tests allegedly passed. Let's get out of here. Let's try media analysis. See what that has to say. Yes, destroy the data. Defaults are fine. Default heads too. And default test patterns. Alright, let's just do one pass, if it even makes it through that. Well, we've got a few defects I see. Yeah, I think that drive's probably hosed. But it does seem kind of suspicious that every single cylinder is being marked as defective. That makes me think there's some kind of bad circuitry involved. Alright, I think I'm going to call it here. This drive has some serious problems. Oh well, the ST225 will serve as a fine substitute. I just need to find something to fill that drive blank up there. Perhaps another hard drive. Alright, let's close it up. Wow, it feels like this thing fought me every step of the way. Totally worth it though. This was definitely the most enjoyable resurrection I performed in a very long time. Now I just need to find an appropriate monitor. And that's something I'll need to stumble upon in person because it's not a good idea to ship those. I've heard too many horror stories. Apparently they get destroyed really easily. And I'm not totally convinced that this ST412 is a complete lost cause. I still think it's some kind of electronic failure. But that'll have to wait for a future video. Huge thanks to all the lovely patrons and channel supporters, without which there would be no purchasing of massive e-waste hauls, and thus no videos like this. All the best. Thanks for watching.